All right, so this is elevator problem. So there's three different questions here, and I'm going to answer them all and show you how to do them. So the first question here is the elevator is going 10 meters a second up. What is the apparent weight? So if you don't know what apparent weight means, that is like the force of normal. So that is force of normal. It kind of just means like if there was a scale underneath you, what would the scale read? So we have this person right here on the elevator, 55 kilograms, and we're trying to find the apparent weight, which is the force of normal. So the elevator is going 10 meters a second up. So because of that, we know there's no acceleration. It doesn't say anything about acceleration here. So we're going to assume there's no acceleration in that problem. So let's draw a free body diagram. So this is going to be our person here. And then because there's no acceleration, we know that force of gravity and force of normal have to be equal. So I'm going to draw force of gravity like this. There's force of gravity. And then force of normal is like that. And see they're equal to each other. So force of normal is equal to force of gravity. So because we know this, we can find force of normal using the force of gravity. So if force of gravity equals force of normal, then we're just going to write force of gravity equals force of normal. And then actually one thing before I do that, so I have to set a direction. So I'm going to set up to positive. Up is going to be equal to positive. Actually, instead of using this one right here, let's use Newton's second law. So F net equals mass times acceleration, right? And then there's no acceleration, so we can take this out. So it equals 0. And then the sum of all forces also equals F net. So we'll do force of normal minus force of gravity equals 0. And then we can just move force of gravity to the other side here, and you'll get force of normal equals force of gravity. And then we just fill it in, so then force of normal equals mass times gravity. Just fill that in again. So 55 kilograms times 9.8 meters a second squared. That is the acceleration due to gravity. And then you should get about 539 newtons. So I'll just set it to 540 newtons. We'll just round it. So about 540 newtons. And then, of course, up is the direction. So that is how you do number one. And then one very important thing with the elevator problems. So force of gravity is always equal to the same thing. Okay, so for every one of these problems, force of gravity is not going to change. The only thing that will change it is if the mass changes or if the acceleration due to gravity would change. But it's not going to change in this scenario because we're still saying we're on Earth. So let's do number 2 here. So the elevator is accelerating at 2 meters a second squared up. What is the apparent weight? So this one's a little bit harder because now we're accelerating. So F net is not equal to 0. Let's draw a free body diagram. So if acceleration is up like this, that means net force also has to be up, right? So net force, F net, is up. Okay, so that means that the total sum of the forces is going to have to be more upwards than downwards, right? So I'm going to set it to like this. And there's only one force that's going up. It's force of normal, right? And then force of gravity is going to be the same thing it was last time. So force of gravity is just equal to that. So force of normal has to be more than force of gravity. So I'm just going to write that in. Force of normal is more than force of gravity. Okay. What we're going to do next here, so I'm going to write down the Newton's second law equation. So we'll do F net equals mass times acceleration. And then, so F net is also equal to sum of all forces. So I'll fill in the sum of all forces. So Fn minus force of gravity equals mass, so 55 kilograms. And then we said acceleration is upwards, right? Or we said it's up here. Yeah, so acceleration is upwards. Remember, positive is upwards, so we're going to make acceleration positive here. So it's plus 2 meters a second squared. If you're confused on why I set force of normal to positive here and force of gravity to negative, it's because force of normal is going to be in the upwards direction while force of gravity is downwards, right? So because I made up positive, force of normal will be positive, and then force of gravity is going to have to be negative. So what we're going to do here, so let's simplify this a little more. So force of normal, and then I'm going to move the force of gravity to the other side. So it's going to be, and actually this is equal to 110 newtons, right? So that's 110 newtons. So I'll set this to positive. Oh, yeah, so I'll set this to positive 110 newtons. And then force of gravity is moved on to the other side. So now it's positive. And then force of gravity is going to be the same thing it was as last time. So I'll just fill it in, equals positive 110 newtons. And then again, same thing as before, mass times gravity. And then this number is the same number that we got over here, which it's not actually 400 or 540 newtons, it's 539 newtons. So I'll just fill that in. Force of normal equals positive 110 newtons plus 539 newtons. And then force of normal equals 649 newtons. And then of course it's upwards. So that is the apparent weight right there. Actually here, wait, let me up. Of course, newtons up. There we go. So 649 newtons up, basically 650 newtons up. And that is for number 2. So that is number 2. And then finally number 3. So same as actually this is supposed to say number 2. So same as number 2, but now 2 meters a second squared down. So it's the same sort of problem. We're finding the apparent weight, but now it's accelerating 2 meters a second squared down. So just like before, I'm going to draw a free body diagram. And now force of gravity is going to have to be more than force of normal, right? So I'm going to draw force of gravity like this, force of normal like that, because now acceleration is downwards. So acceleration is down, which means F net has to be down. So force of gravity is more than force of normal. All right. So for this one, I'm going to do the same sort of setup as over here. So force of normal minus force of gravity equals, and then mass times acceleration. So mass times acceleration. Now, one thing to remember here, so force of gravity never changes. So just because force of gravity is larger than force of normal, it means that force of normal is going to be smaller than force of gravity, okay? So I know this sounds a bit confusing, but we're not going to increase the force of gravity's magnitude. We're going to decrease force of normal's magnitude, okay? So what I mean by that is that force of normal is going to be smaller than it was like over here, for example, or over there. Force of gravity isn't going to become any bigger, okay? So force of gravity stays the same. Okay, so let's fill this in. Actually, no, I'm going to move force of gravity to the other side here. So it's become positive force of gravity over here. And now let's fill in. So force of normal equals 55 kilograms. And then remember, so acceleration is downwards. And if we set up to positive, acceleration has to be downwards, right? So it's going to be negative 2 meters a second squared. And then plus the same thing as before, so 55 kilograms times 9.8. Okay. And then what this should equal is 529 newtons, or sorry, 429 newtons. If you put in your calculator. And then of course it's up, so 529 newtons up. because this is equal to negative 110, and then this is equal to 539, and then you just subtract the two, or add the two, I guess, and you get 429. All right, so that is elevator problems. So some things to remember: force of gravity always stays the same. It's the force of normal that changes, okay? Then apparent weight is force of normal. And then if there is no acceleration, so if it just says, oh, there's like a velocity of this, but there's no acceleration, then force of gravity and force of normal are equal to each other, okay? All right, that's about all. So let me know what you'd like to see next in the comment section.